Hi everyone, welcome to the class guys. Kindly confirm that am I audible to you or not? Hi, morning Shillong. Okay. Okay. So, can you please tell me what topic are we discussing in the previous session? What was the topic? I guess we have started with the electrolytic conduction, electrolytic conductance actually. Okay, so let's start with the question guys. Whatever formulas we have discussed in the previous session, okay, attempt this question. The conductance of a salt solution AB measured by two parallel electrodes of area 100 centimeters square separated okay, it's okay Shillong. Please attempt this question. Separated by 10 centimeter was found to be 10 to the power minus 4 ohm inverse if volume enclosed between two electrodes contain 0.5 mole of salt what is the molar conductivity of salt same concentration. Options are 0.01, 0.02, 2 into 10 to the power minus 5, D, none of these. Please solve this question. Just confirm once after attempting this question. Hi, welcome. Good morning, Tamalong. 2 more minutes, guys. Very good, Arnie. Oh, is that Paul? Okay. Okay, so let's start with the solution, guys. Just look at your screen. Quite easier question. Again, these are simply formula based questions, and yes, you will find these questions in your examinations as well. First of all, let's calculate the G star, which is nothing but the L by A, which is the cell constant actually. L is given to us is 10 and area is 100. On solving, we will get the 0.1. G is given to us 10 to the power minus 4 Simon, or we can say the ohm inverse. We can calculate the volume. It is nothing but the area into length. So this is 100 into 10, which is 1000 centimeter cube, which is nothing but the 1 liter. Okay. Now simply calculate the K, which is G into G star. 0.1 in 10 to the power minus 4, which is nothing but 10 to the power minus 5. Now simply put these values and we will have the solution. Lambda m is equals to K into 1000. Area is 100, length is 10 upon 0.5, which is number of moles. Okay, so this is 10 to the power minus 5 upon 1000 upon 0.5. On solving, we will have 2 into 10 to the power minus 2. Simon, centimeter square mole inverse. Okay, please copy this. I hope so everyone is clear with the solution. If anyone is having any doubt, you can please ask me. Raise your hand those who are having doubt in this solution. This is given in the question, na? Oh, 1 second. Oh, this is not 100 centimeter, guys. This is 10 centimeter. By mistake, that is written as 100 centimeter. That is 10 centimeter. If we use the 100 centimeter, then answer will be changed. Please correct it in the question. Length was the 10 centimeter, not the 100 centimeter. Done? Okay. Yeah, I know that in the question that was by mistake written as a 100. That was 10 actually. Okay. Please correct that. Okay. So guys, let's move on to the next part, which is variation of conductance conductivity lambda m or lambda eq with dilution. Okay, so let's start. First is conductance. Definitions we have already discussed, even the concept as well. Now let's see that how they are affected on dilution. Okay, see, conductance is actually increases in case of the both type of problems. So we can say in both the cases, whether it is a part of the strong electrolyte or the weak electrolyte. Okay, but yes, reason is exactly different from different for both type of solutions. Okay, it will increase definitely, but reason will be different. Okay, so let's check out what is the reason behind that. You can copy this statement with me and then we will discuss. Okay, that conductance of each solution weak electrolyte or strong electrolyte will increase with dilution, and reason for both is different. Okay, just copy it and then keep your pen inside your notebook and just focus on the screen. Just copy this and then be relaxed. Done? Okay guys, so now just look at your screen. Need not to copy anything now. First part is for the weak electrolytes. Actually what happened, we know that the weak electrolytes are, means the degree of dissociation of all the weak electrolytes is very less. Okay, and obviously whenever we dilute them, extent of ionization will increase. It means that conversion into the ions will be the more. Okay, means dissociation will be the more. If dissociation will be the more, it means we will have the higher number of ions, and if we are having the higher number of ions, then the conduction will be increased over there. Okay, so just because on dilution alpha increases, with increase in volume, number of ions will get increased, and due to which conductance will also get increased. So this is the reason for the weak electrolytes. Okay, I hope so it is clear to everyone. If not, then you can please ask me. And yes, you have to copy it, that on dilution volume increases, V is the volume, increases, alpha will also increase. It means number of ions will increase, and along with this G will increase. Okay, so you can remember this one. I hope so this is clear to everyone. Now check out this strong electrolyte part. See, for the strong electrolytes, if we talk about the concentrated solutions, concentrated means the acid part, or we can say the whatever acid, base or the salt are there, their concentration will be very high. Means if we talk about per unit volume of solution, the quantity of the electrolyte will be very high. Okay, if quantity is very high, it means that number of ions should also be very high. So what happened actually, there is a very strong force of attraction between these ions. Okay, and due to that strong force of attraction, their movement is very slow in case of the strong electrolyte, or sorry, in case of the concentrated solutions. So whenever you dilute them, what happened on dilution, the force of attraction which is being act between them before, or we can say earlier, is decreased now. And after that decrease in the intermolecular forces, or we can say that strong electrostatic force, their movement increases with increase in the volume. Okay, that's why we say that on increasing the volume, or we can say, or on dilution, the attractive force between the ions, which was per unit volume, was very high initially in case of the concentrated solution, is now decreased. Okay, and due to that decrement, the ions will be free to move. If ions are free to move, it means that they are increasing the conductance. Okay, so this is the reason for the strong electrolytes. Okay, so see, reasons was totally different. For the weak electrolytes, with the increase in dilution, number of ions were increasing. Okay, that was the reason for the increase in conductance. Whereas in case of the strong electrolytes, what happens on increasing the volume, it decreases the intermolecular forces, or we can say that attractive force between the particles, and in per unit volume, number of ions increased and conductance increased along with that. Okay, so now you can please copy it, that. And yes, you can remember one thing, that 100% means strong electrolytes ionized 100% at all concentration. Okay, but look at this, if concentrated solution, sorry, in concentrated solution, density of ions will be high, but on dilution, density of ions decreased. Therefore, conductance increases. See the different scenarios. This is the case of concentrated solutions. This is the attractive force. Okay. Now on dilution. What will happen? The distance between the ions will get increased. Okay. And due to that increase, this attractive force will decrease now. Look at this. Obviously, now they are free to move. Please copy. Clear? Is this clear to everyone? Okay, good. Copy. Okay, everyone. So let's move on to the next part. Number 2 is conductivity. which is kappa. Guys, tell me one thing. See, we have learned that conductivity is nothing but it is the conductance of ions in 1 ml solution, or we can say per ml solution. On dilution, whether the number of ions per ml will get increased or decreased. My question is, on dilution, the number of ions per ml solution will be increased or decreased. You can consider anything, strong or weak electrolyte. Whatever part you think is easy to understand for you, just consider that, strong or weak. But just answer my question, that on dilution, number of ions per ml solution will be increased or decreased. Yes, absolutely correct. It will be decreased. Okay. So if number of ions per ml solution is decreased, it means that conductivity will also get decreased. Okay. So absolutely correct. Yes, on dilution, number of ions per ml solution decreases because volume is increasing over there. Okay. So we can say, since conductivity is the conductance of all ions present in 1 ml of solution and on dilution, number of ions per ml decreases. Therefore, conductivity decreases. Okay. Number 3, lambda m or lambda eq. Both behaves in the same manner. Okay. Just look at this. On dilution, volume will increase. It means that concentration will decrease. Okay. We know that lambda m is equals to what? 1000 into kappa into m. Sorry, kappa upon m. Okay. And yes, one more important thing, on dilution kappa decreases. Okay. So along with that, see, okay guys, wait a minute, look at the screen, just look at your screen, stop writing that, else you will get confused in that now. Okay. Look at the formula. For the lambda m, formula was 1000 into kappa divided by m. Okay. So on dilution, actually there are two terms which are actually involved in this. First one is the molarity. On dilution, I can say volume will increase. So if volume is getting increased, we know that molarity is nothing but the moles by volume, which is inversely proportional. Therefore, m should decrease. Okay. So according to this, lambda m should increase. This is our first point. Okay. Increase in volume, will decrease. Sorry, increase in volume, molarity will decrease, and due to which we can say that lambda m should increase. But Kappa is also there. We know that with increase in volume, kappa decreases. If kappa decreases, then lambda m should also get decreased. So actually there are two terms, okay, and yes, out of these two terms, one should be the dominating one, okay. So out of these two, actually this is experimental that molarity is the dominating factor out of kappa and the m, okay. So we will decide the variation, or we can say the effect of the dilution on the lambda m by the help of the molarity, because that is a dominating factor, okay. That's why we can say that out of these two factors, molarity was the dominating. That was just because of the experimental phenomena we have determined that, and after that we have concluded, okay. So I'll decide the lambda m should increase with dilution, okay. So I can say that experimentally it was observed that m is dominating. Factor, okay. Therefore lambda m or lambda eq increases on dilution. I hope so this is clear to everyone. Clear? Is there any confusion about this? Anyone? Okay. Now I'm just concluding it. Ultimately you have to remember that terms, that what is actually effect of dilution. Slide 2. So which one? Slide 2. Okay, please copy this first, and after that I'll shift to the previous slide. Okay, Temelon. First copy this, then I'll shift to the previous slide. Conductivity partner. Okay, I'll show you. Please copy this first. Confirm once after copying that. Temelo, confirm after copying this page. See. Inform once after copying that. Now you can just remember this part, that on dilution G increases, kappa decreases, lambda m or lambda EQ also increases. That's it. This is the summary. Just copy this. You have to just remember this. Done? Okay, so let's move on to the next part. Case 1, variation of lambda m with concentration. C. For strong electrolyte. Okay. Look at this. This is lambda m and this is your concentration. Okay. So when we observe this graph, this actually looks like this. This is for KCl and this is for HCl, and this point is known as lambda naught m or lambda infinite m. Okay, we can say on moving, I'll explain you that how we have got this graph. On moving left on graph, molarity, which is concentration, decreases and lambda m increases. Okay. First of all, copy this one. Lambda m naught is limiting molar conductivity. Or we can say molar conductivity at infinite dilution. Okay. Question is how we have got this limiting molar conductivity. Guys, look at this once. If we say concentration, we can say that volume tends to infinite means we have very huge volume, okay. We can say molarity is inversely proportional to the volume, and if something is inversely proportional to infinite, because I'm going to put the value infinite at the place of the volume, then m, or we can say the concentration, I'll simply write it as a C. I can say this is C. Then C would be tends to 0. Okay. Means concentration will be what? Approximately 0. How it is 0? See, we have learned that concentration is nothing but the amount of solute in the solution. Okay. Think about it. If we are making volume infinite, so with respect to the volume, the quantity of the solute will be negligible. If quantity of solute is negligible, then we can say that concentration is what? Almost negligible. That's why we are saying the concentration tends to 0. Okay. Tends to means it is approaching to 0. Approaches to 0. Okay. Then we know that lambda m is what? Lambda m is what? Inversely proportional to the concentration. So we can say that lambda m is inversely proportional to the concentration, and yes, something upon 0 is nothing but the infinite. So lambda m tends to infinite, and this is known as what? Limiting molar conductivity, which you can write like this: lambda naught m or lambda infinite. Means this is nothing but at the infinite dilution. Okay. When concentration approaches to 0, the conductivity, the molar conductivity defined is known as what? Limiting molar conductivity, or we can say molar conductivity at infinite dilution. Got it? Okay, raise your hand those who are having doubt in this one. Is there anyone who is having doubt in this one? Okay. Now the question is that how we have plotted that graph. For that you need to remember this equation. This is your Debye Huckel on Sager equation. Okay, lambda m is equals to lambda naught minus a under the root c. This is your equation that you need to remember. Okay, and this we have plotted on the y-axis and this one at the x-axis. Okay, so lambda m is molar conductivity at any concentration. Is molar conductivity at any concentration. C is your concentration and A is your constant of solvent. Which takes into account viscosity and dielectric constant. Of solvent. Okay. Please copy it. Okay, let's move on. Case 2. Weak electrolyte. Here alpha is inversely proportional to 1 by root C. Okay, and if we look at the graph, that is like lambda upon root C. These are the graphs. Okay, this for the weak electrolytes. Copy. Done. Okay, next, Kohlrausch law, and quite important. Kohlrausch law, it simply says that at infinite dilution every electrolyte behaves as a strong electrolyte. Why? Just because if you are saying the infinite dilution, it means that you have diluted the electrolytes to the extreme points, okay, where there is a no point left where they have a chance to get associated with each other. Okay, they will simply get separated out. Okay, so it simply says whether we are having the weak electrolyte or the strong electrolytes. The strong is definitely get dissociated. The question is only for the weak electrolyte, and we know that on dilution the ionization for the weak electrolytes increases, and we are saying I'll dilute it up to the infinite point. Okay, so what will happen? Whatever substances, or we can say the molecules of the weak electrolytes are there, they all will get ionized. Okay, and they will behave as the strong electrolytes. That's what the Kohlrausch law says. Okay, so first of all you can copy this. At infinite dilution, each and every electrolyte is 100% dissociated, and ions are completely independent from each other. So, limiting equivalent conductivity of any electrolyte will be equal to sum of limiting equivalent conductivity of cation and anion. Okay, this is a Kohlrausch law. Just copy it, and after that we will learn little bit more about it. copy and then confirm. Okay, so let's move on. We can say lambda naught m can be written as a sum of lambda of cation plus anion, okay, for the electrolyte. Now, let's talk about NaCl. If I would like to write the lambda naught m for NaCl, I know, guys, just look at your screen very carefully. I know that the NaCl ionized to give Na plus and the Cl minus. So we have to simply write it like this: lambda m for the Na plus, or you can simply write lambda naught of Na plus plus lambda naught of Cl minus. That's it. Okay. If I have MgCl2, I know that MgCl2 can be written as what? Mg2 plus plus twice of Cl minus. So I'll write it lambda naught of Mg2 plus with lambda naught of Cl minus. Just because we were having the 2 Cl minus ions, simply I'll put it 2 here. Okay. Whatever number of ions are there, I have to put them. Are you getting this? Please copy it. One more thing, we know that lambda m can be written as what? N factor into lambda eq. Okay. So if I would like to write the lambda eq, I can say it is nothing but lambda m upon n factor. And I know that how to write the n factor. Let's say suppose for the MgCl2, I want to write the lambda eq. Okay. So lambda eq for MgCl2. Okay. So this is nothing but lambda of Mg2 plus 1 by 2 plus 1 by 2, not 1 by 2, lambda naught of Cl minus, because Cl minus has a n factor 1. Okay, I hope so we have knowledge about the n factor. I guess some of you are confused. See, MgCl2, look at this. MgCl2 on ionization will give you Mg2 plus with twice of Cl minus. Okay, I am just asking about the n factor. For the ionic species, whatever charge is present is the n factor. Here the charge is 2, that's why n factor is 2. Here charge is 1, that's why n factor is 1. I am simply dividing that. I am using this formula, that lambda EQ is nothing but lambda naught upon n factor. That's it. Okay? I hope so this is clear to everyone. Done? This is the question for you. We have Ca3PO4 whole twice. On ionization, it will give you thrice of Ca2 plus with twice of PO4 3 minus. Write lambda m not and lambda EQ. Lambda not EQ means you have to write the limiting molar conductivity and limiting molar equivalent conductivity for this one. Done? Okay, so just look at this. Those who are finding difficulty in writing this one, just look at the screen. Just look at the screen. I'm telling you a simple trick. First of all, let's write the lambda naught m. Okay. Simply just put the number of ions into lambda naught of the calcium 2 plus ions plus twice of lambda of the PO4 3 minus. Get it? Easy. Whereas in case of the lambda EQ, whatever ions are there, just divide them. Ions as in the charge. With the charge you have to divide that. So here the charge was 2, that's why I am dividing it with the 2, lambda of Ca2 plus. Here the charge was 3, therefore I'll divide it by the 3, lambda naught of PO4 3 minus. That's it. Get it now? In case of the lambda EQ, just divide 1 by that charge, whereas in case of the limiting molar conductivity, simply multiply. Okay. Okay, just practice a simple question. Guys, look at your screen. Copy this question with me. For NaCl, CH3COH and HCl are 390.1, 420.0 and 321.2 respectively. Determine lambda naught m for CH3CONA. Okay. Guys, now stop writing it. Just look at your screen. It's a very simple question, just a rearrangement type of question. First of all, let's write the lambda naught m for the NaCl. This should be the Na plus and Cl minus. Then we are having the CH3COH. I can say it should be the CH3 CO minus plus H positive. Then we have HCl. I can write it as a H plus and Cl minus. Okay. We have to calculate. Lambda naught for CH3CONA. So on ionization, I should have two ions, this ion and this ion. Okay. Assume this is equation number 1, this is equation number 2, this is equation number 3. This is we have to find out. So we have to arrange the equation number 1, 2 and 3, or we can say you have to add, subtract equation number 1, 2 and 3 in such a manner that finally you should get the equation number 4. Okay. So what do I need in equation number 4? I need first of all CH3CO negative ions, which is present in equation number 2, and Na plus ions, which are present in the equation number 1. Now look at this. If I add equation number 1 with equation number 2, what will happen? That I'll get this ion and this ion. And these two ions are actually present in the equation number 4. I have required only these two types of ion. But there is a problem. If I simply add 1 and 2, I'll get the H plus and Cl minus as well. Okay. H plus and Cl minus as well, which is not required according to the final equation. Okay. But yes, you can check out in equation number 3, these two ions are already present. So if I subtract equation number 3 from here, so extra HCl part will simply get cancelled here, and I'll only left with Na plus and the CH3CO minus. Okay. Is it clear to everyone? Confirm once. Is it clear to everyone? Okay. Simply now you have to put the values and you have to solve it. Lambda naught m for the CH3 CO minus or CONA. Okay. So in the equation number 1, which is NaCl, value of NaCl is 390, CH3COH is 420. So 390.1 plus 420 minus I have 321.2. That's it. Solve it and you will have your answer. Please copy this. Done? Guys, look at your screen. Applications of Collar's law. First, determination of limiting molar conductivity of weak electrolyte. Okay, that we have simply discussed. Now second part is in the determination of degree of dissociation alpha and Ka of weak electrolyte. Okay, you can use the formula alpha is equals to lambda m upon lambda naught m. This is the formula for the alpha, and after that we can use the Ka equals to C alpha square upon 1 minus alpha. Please copy. Okay, over. Cool. So guys, that's all about the electrochemistry. Okay, we have to discuss few important questions now. Okay, so before that, let's take a refreshing break for the questions. Quickly in the 5 minutes. I'll see you in the 5 minutes. Hi guys, welcome back. Let's practice a few questions. Am I audible to everyone? Tamelong, Shillong, guys, can you hear me? Okay, so let's start. The conductivity of an aqueous solution of weak monoprotic acid is 3.33 into 10 to the power minus 4 ohm inverse centimeter inverse at a concentration of 0.02 molar if at this concentration degree of dissociation is 0.05, then calculate value of lambda naught m. Guys, you have everything. You have formulas, concept, each and everything. Just put the values and solve it, and tell me the answer. And I expect that everyone is able to solve this question. Just inform me once after solving this question. Okay, let's check out what's the answer for this one. Lambda m is definitely k into 1000 upon m. K is 3.33 into 10 to the not 33, yes 3.33 and 10 to the power minus 4 into 1000 upon concentration was 0.02. Okay. Simply remove the decimal and I'll have 333 upon 2 into 10 to the power minus 1. Okay, this is the lambda m, and this is okay, this is 16.65. okay, then we have alpha is equals to lambda m upon lambda naught m. Alpha is 0.05 and this is 16.65 upon lambda naught m. So this is nothing but triple three. Very good. How many of you has got the correct answer? Raise your hand, those who has got the same answer. Okay, very good. Next question. This is in AIMS 2017. Okay. If limiting molar conductance of Ca2 plus and Cl minus ions are 119 and 76.3 Simon centimeter square mole inverse respectively, the limiting molar conductivity of CaCl2 is option A 347, B 271.6, C 42.7 and D 195.3. Please solve this. B. Okay, very good, Kpang. Okay, let's solve this. Very easy question actually. Lambda naught of Ca2 plus is 119. Lambda naught of Cl minus is 76.3, and they are asking lambda naught of CaCl2. So what can I do? This is nothing but Ca2 plus twice of Cl negative. So this is nothing but 119 plus 2 into 76.3. So 119 plus 6, 12, 5.6, 271.6, which is option number 2. Okay, easy question. How many of you has got the correct answer? Raise your hand. Those who has got the correct answer. Okay, really nice. Next question. The number, this is question from NEET 2016. NEET 2016. The number of electrons delivered at cathode during electrolysis by a current of 1 ampere in 60 seconds is option A 3.75 into 10 to the power 20, option B 7.48 into 10 to the power 23, option C 6 into 10 to the power 23, and option D 6 into 10 to the power 20. Okay, and charge on one electron is, this is given to you, charge on electron is 1.6 into 10 to the power minus 19 coulombs. Please solve this question. Done? Okay, 2 more minutes for this question. Okay, so let's begin, guys. Just look at your screen. They are asking you have to calculate the number of electrons delivered at the cathode during the electrolysis by a current of 1 ampere in the 60 seconds. I hope so. We know that Q, which is charge, is I upon T. Okay. Current is 1 ampere, time is the 60 seconds. Okay. And yes, other than this, we know that Q is equals to Ne. And where is number, N is what? Number of electrons, we can say. So Q is nothing but 1 by 60, and we need to calculate electron is the charge on electron, which is 1.6 in 10 to the power minus 19. So N is equals to what? 1 upon 60 into 10 to the power minus 19 into 1.6. So this is nothing but 10 to the power 19 upon 1.6 into 60. So this is 10 to the power 19 10 to the power 19 upon 96. Simply solve it and you will have your answer. One thing, guys, this charge is in farad. Okay. First of all, you have to convert it into the coulombs as well. Convert this into the coulombs as well. Okay. We know that 1 farad is equals to what? 96500 coulombs. So this is 96500 upon 60 coulombs. So put this one actually. At the place of the Q, you have to use this 96500. This is 96500. This is 96500. Okay. Next question. How many farad charge, this is in AIMS 2016, is required for KMnO4 to Mn2 plus. Options are 3 farad, 2 farad, 5 farad, and then 1 farad. Yes, I equals to Q by T. Do we have put something else? Oh wow. Yeah, obviously that is this is I equals to Q by T. Wow. I hope so you have understand the concept. Why you have noticed this at the end of the problem? You should notice it at the beginning of the problem, na? Okay, I is equals to Q upon T. Q is equals to what? I into T. Okay, so Q is I was 1, T is 60. Okay, and then use Q equals to NE. Okay, that's cool. It's okay, it's okay. Then use this one. Okay, just confirm after changing this, just confirm the answer. And yes, after that you have to solve that next question. Please change it and then tell me the correct answer. And after that, solve this one. Okay, C for the AIMS 2016, na? Okay. Guys, look at this. I think we have discussed such type of problems that in these cases just determine the n factor. Okay. Here this is plus 7, this is plus 2 and the change is of 5. So 5 is what? N factor. There is nothing but the 5 farad. Okay. So yes, option C would be the correct answer for this one. How many of you has got the correct answer? Please raise your hand. 5 farad. Okay. Very good. Move on to the next question. If this is NEET 2016. NEET 2016. If the E0 cell for a given reaction has negative value, which of the following gives correct relationship for the values of delta G naught and K equilibrium? And the options are delta G naught is less than 0 with K equilibrium greater than 1. Delta G naught is less than 0 with K equilibrium less than 1. C. delta G naught is greater than 0, K equilibrium is less than 1. Option D, delta G naught is greater than 0 and K equilibrium is greater than 1. Please solve this question. This is in NEET 2016. Okay. Very good, Kirpang. What about others? Okay, so guys, let's solve this question. We know that delta G naught is nothing but negative of NF E naught cell. In the question, they are saying E naught cell is negative. This value is already negative. And here we have also got the negative. So negative and negative will become what? Positive. So delta G is positive. So we can have two options where delta G is given as a positive, which is option number C and D. Now let's discuss for the equilibrium constant. We know that K equilibrium is nothing but 0.059, E naught cell is equals to 0.059 upon N log of K equilibrium. Okay. They are saying that E naught cell is negative. So question is, if E naught cell is negative, what can be the value of K equilibrium? This is only possible when K equilibrium is less than 1. If K equilibrium is less than 1, then we can have the E naught cell as a negative values. So I can see that this is satisfying only in the option number C. Okay, this is how you can solve it. Understood? Is there any problem in this solution? Okay. By the way, how many of you have solved that earlier? I mean, before me? Okay, good. Next question. This is in AIPMT 3.75. For the question of electrolysis, na? Yes, option A is the correct answer. Okay, we haven't marked the correct. Option A is the correct answer for this one. Okay, this is the correct answer. This is in AIPMT 2014. Question is, when 0.1 mole MnO4 2 minus is oxidized quantity of electricity required to completely oxidize MnO4 2 minus 2 MnO4 minus is. Options are 96500 coulombs, B 2 into 96500 coulombs, option C as 9650 coulombs, option D 96.5 coulombs. Please solve this question. Done. Okay guys, let's solve this question. You guys are taking too much of time. This question doesn't deserve so much of time. See, MnO4 2 minus is getting converted into the MnO4 minus. Calculate the N factor. Na? So this is Mn plus 6 oxidation state, and here it is in plus 7 oxidation state. So what can I say? The N factor is nothing but 1. So ultimately it is using the 1 farad of electricity, but 1 farad is when we have the 1 mole of the MnO4 minus. In the question they are saying we have only 0.1 mole. So obviously if I have the 1 mole If I use 1 mole, then I can have the 1 farad electricity. If I am using 0.1 mole, then I'll have 0.1 into 1 farad of electricity. Just convert it into the coulombs. 0.1 into 96500. So on solving, I'll have the 9650 coulombs. This is in option number C. How many of you has got the correct answer for the given question? Okay, really nice. Good. Those who haven't got this, please copy. Then next question. Next question is from the AIMS 2014. Guys, you haven't decided any day till now for the doubts of the solutions. This is from AIMS 2014. Amount of charge is required to convert 17 gram H2O2 into O2. Options are 1 farad, 2 farad, 6 farad, D, none. Let me check it once. I guess so. I have sent it in the every group, but I'll check it once. Wait. By the time you can do this question. If I haven't sent that, okay, if I haven't sent that, I'll share it right now. I'm sharing it right now, okay? Please solve this question, tell me the answer. Okay, I have sent that. You will get it soon. It's on the way. Okay, what's the answer for this question? Okay, let's see. H2O2 is getting converted into the O2. Let's calculate the n factor first. This is -1, this is 0. Changes of 1 into 2. So n factor would be the 2 here. So we can say the 2 farad or 2 farad for the 1 mole. Now let's calculate the number of moles. Moles will be given mass upon molar mass, which is 17 upon 34, which is 1 by 2. So I can say this is 2 into 1 by 2 farad. So which is 1 farad. Yes, option A would be the correct answer. How many of you has got the option A as the correct answer? Please raise your hand. Now many of you has definitely forget the how to calculate the n factor. Now raise your hand those who forgot to calculate the n factor. Those who don't know how to calculate the n factor. Oh, no one is raising their hand. It's okay. Okay guys, that's all about your electrochemistry. We are almost about to finish the physical chemistry section. Okay. We are left with the solid states. And then chemical kinetics, surface chemistry, and lastly the thermodynamics only. Okay. And after that we will have the inorganic section. And yes, next, that is by tomorrow, we are going to start the solid state chapter. Okay. So I'll see you tomorrow, guys. Till then, take care. Bye bye. Have a good time. And yes, I'll share the assignment of electrochemistry as well with you. Okay. Very soon. Most probably by tomorrow. Okay. So take care. Bye bye.